Hey, what's going on, guys? In this video we are going to see how to solve an exact differential equation. Now the standard form of the exact differential equation will look like this. We will have m of x comma y plus n of x comma y multiplied by y prime. That will be equal to 0, and this is only exact if the derivative of m with respect to y and the derivative of n with respect to x are equal. Otherwise this is not exact, so we will stop right there and say this is not exact. Now if these two are equal, we go to the next step. In the next step what we say a function of x, a function of partial derivative with respect to x is equal to m, that is this first function, and also we will say function with partial derivative of y is equal to this second n of x comma y, and then we take the integration of this one and find the function, and we take the derivative of that one with respect to y and compare with this one, and then we find the final solution. Now when we do this example problem, you will see what it is. Now here we have this problem, y cos x plus 2x e power y and all these things. This is the first one. This is our m of x comma y, and the second one is n of x comma y. Now the first thing is we have to take the derivative of this one with respect to y. Now when we take the derivative of this one with respect to y, we treat x as a constant. So here what we have is this y will become 1. So this is going to be just cos x. And here this e power y remains the same because derivative of e power y is still e power y. So we will have 2x e power y. Okay. Now the next thing is we are going to take the derivative of this n with respect to x. So n of x, we treat y as a constant. So this sin x, since we have x, we have to take the derivative of this one. If you take the derivative of sin x, that's going to become cos x. And here we have x squared, that's going to become 2x, and e power y remains the same. So we will have 2x e power y, and since 1 is a constant, that's going to be 0 when we take the derivative. Okay. Now here if you look at this one, m, y and nx are equal. So this is an exact differential equation. Now after we find out this is an exact, we go to the next step. The next step is we equate this first function m with a function with respect to x. So we will say f of x, like f is a function and the partial derivative of function of that function with respect to x is equal to this m, and that is y cos x plus 2x e power y. And also we will say this another function, partial derivative of that function with respect to y is equal to this function, that is sin x plus x square e power y minus 1. Okay. Now after we equalize to this one, we keep one of these. So let's keep this one as it is, and then we integrate this one, because we are going to integrate and find the function and take the derivative of this one with respect to y, and then we are going to compare with this one. From that one we will find a constant. Now you will see when we do that. Now let's continue that one right here. If I integrate this one with respect to x, we will have function of x and y. If I integrate this one with respect to x, y doesn't change because y is just a constant. So cos x is going to be just sin x, right? So we will have y sin x, actually integrate with respect to x, we will have y sin x, and also we will have 2x. If you integrate this one, that's going to be 2x squared divided by 2, so plus 2x squared divided by 2, so 2 cancels, we will have just x squared e power y. Okay. And also we have to add a constant, but that constant must have a function. It should be a function of y, because we are doing the integration with respect to x. This is a partial integration, so we are doing the partial integration with respect to x, so we have to add a constant with respect to constant that should be a function of y. Now here the thing is we have to take the derivative of this one with respect to y to compare with this one. Now let's go ahead and do that. If I take the derivative of this one with respect to y, we treat x as a constant, so this is going to be what we will have. This y will become 1 and sin x remain the same because we are just doing the derivative with respect to y. So this is going to be just sin x, and here e power y remains the same, so we will have just x square e power y and when we take the derivative with respect to y, this function of y will become h prime of y. Now if you compare this one with this one, we have everything look the same except this h prime of y. So from this one we know that h prime of y is equal to -1. But to express the final answer, this is going to be our final answer, but we have to find out what is this h of y is. That's the one we have to express finally. Okay, now here we have h prime of y that is equal to -1. So we have to find out the h of y. In order to find the h of y, we have to integrate this one with respect to y. If we integrate this one with respect to y, this is going to be just -y. So we just have to add this word, instead of h of y, we have to add this -y, and that's going to be our final answer. Now let's go ahead and express that one in the another page. Okay, let's copy the whole thing. F of xy x comma y is equal to y sin x plus x square e power y sin x plus x square e power y, and instead of this constant we will add this -y, but this is not going to be the final answer, because at the end we have to equate everything to the constant. We shouldn't write in terms of a function, we just have to equate everything to the constant, and that's going to be our final solution. Y sin x plus x square e power y minus y is equal to a constant, and this is the solution of this exact differential equation. I hope you guys find this video helpful. Thanks for watching, and don't forget to subscribe. And if you want to see more videos on differential equation, there are a bunch of videos in my playlist, and I hope you guys watch those too. See you next time.